All right, so let's deal with some fractions just one more time on an advanced level. As you can see from this, this frightening equation here, solving for x. Well, what type of equation is it? Is it still a linear equation? If I examine the exponents, there are understood ones on both of these, so indeed this is still a linear equation. It just looks intimidating because we have portions of it contained within fractions, right? Okay, so just like with those simpler ones, like for example this one here, you might go, simpler? What are you even talking about? In order to get rid of those fractions, you're going to multiply both sides of this by the least common denominator. So it's like we got fourths and we have tenths. So the idea on that least common denominator is you take the larger of the two numbers and you check to see if the smaller one goes into it. So here I have 10. I want to check to see, does 4 go into 10? No, it sure doesn't. Okay, so then I take the next multiple of 10, which would be 20. 10 times 2. And now does 4 go into 20? It sure does. It goes in there 5 times. So if I multiply both sides of this equation by 20, then the fractions will vanish. And that's what we want because it makes this problem so much easier to deal with. So I'm going to distribute the 20 through both of these terms on the left-hand side. And of course, the 20 will hit that -1 as well. So I'm going to rewrite this just a little bit. And I would have 20 times this quantity 3x plus 7 over 4. And then also 20 times the quantity 2x plus 1 over 10. And I can't forget to multiply the right-hand side by 20 as well, so -1 times 20 gives me a -20. Okay, now rather than, let's say, distributing this 20 across the top, the whole reason why I chose this 20 is because 4 goes into it and 10 goes into it, and I'll be able to dissolve my fractions. They're going to divide out. And think of this, if you will, as something over 1, like 20 over 1, 20 over 1 over here. And yeah, you could do top times top or bottom times bottom. But as we've seen on some of those other problems, I can go ahead and divide out any common factors on both the top and the bottom. Like, for example, the 4 down here and the 20 here, they both share a common factor of 4, right? I can rewrite the 20 as 4 times 5, and then I can see that this common factor of 4 divides out. Or I can also think of it simply as 20 divided by 4 gives me this 5 that's right there. Okay, so I'm going to rewrite this term now as 5 times the quantity 3x plus 7. And then I want to do something very similar over here on the second term. So I can think either like 20 divided by 10 is 2, or I can factor this. I know 10 goes into it. 10 goes into it 2 times. And then I can very easily cancel out that common factor of 10. But I still got a 2 there. Got to bring it down. Times 2x plus 1, and then bring down our -20. All right, now you can see no fractions. Very simple equation to solve. I do have some distributive property that we will have to do, which is not as big of an issue now without the fractions. So I'll distribute the 5 to that first set, 15x plus 35, and then distribute the 2 on the second one here, plus 4x plus 2 is equal to -20. All right, I want to combine my like terms because I do have some. We have a 15x, we have a 4x for a total of 19 of those things. And then we also have these constant terms, 35 and 2 to get 37. And look at that. I am running out of room because that's what happens. Now, very straightforward linear equation. I want to get rid of this 37, so I will subtract that 37 from both sides. Now, if you can just subtract it to the other side without actually having to write it down, I'm perfectly on board with that. You can just write down, hey, I'm left with 19x is equal to a negative 57, it looks like. And now the last step, of course, is just to divide by 19. Divide by 19, divide by 19. Cancel, cancel, and I'm left with x is equal to whatever negative 57 divided by 19 is. Well, it ends in a 7. That could be something like 3. Let me just try 3 here. Let's say 19 times 3, that'd be a 27. And then 3 plus 2 more is 57. Yep, checks out. It was a negative 3. Of course, you could have gently inserted that into the calculator and gotten negative 3 as your answer. And so what does that negative 3 mean as the solution to this? Of course, if I were to take that negative 3 and put it into each of these positions here, simplify that left-hand side, it should boil down to just a negative 1. It was a linear equation with a power of 1, and we only expected to get a single answer. And there you have it. So even with a problem as complicated as this one here, we're still using that same strategy, multiplying both sides by the least common denominator to get rid of all the fractions.